Welcome to the SEAM, Statistical Energy Analysis Software Overview, presented by Cambridge Collaborative. The SEAM software is used across a wide variety of industries for statistical energy analysis. It's used for vehicles of all types. For quite some time it's been used for acoustic and vibration studies and designs for aerospace applications, airplanes, helicopters, and launch vehicles or rockets. It's used for structure-borne transmission predictions, for ships and heavy machinery and ship suppliers. It's used for ground vehicles, such as passenger vehicle manufacturers or OEMs, heavy truck and construction vehicle manufacturers, as well as their material and component suppliers. And it has uses outside vehicle industries, for example, for oil platform acoustic and vibration design, consumer products such as generators or dishwashers, and even architectural acoustics in some cases. SEAM offers unique capability and is best in class as the only analysis tool that can reliably predict high-frequency structure-borne noise and vibration transmission. The SEAM software has been optimized over many years. The system resources are minimal. It's very fast to update and run a model, on the order of a minute or less for all frequencies for a typical full vehicle with trim modeled. The GUI allows a modeling without need for detailed geometry or nodes. This again speeds up the model update significantly and makes morphing a template model to a new vehicle very easy. Finally, SEAM complements testing very well and makes it very easy to directly incorporate measured damping, absorption inputs, or other quantities direct from Excel, the clipboard, or another file. SEAM's also very useful at very early phases of design when test hardware is not yet available. It can be used to predict some early phase acoustic and vibration predictions when hardware is not available and complement testing in that matter. There's a brief demonstration of the software now, showing how SEAM can be used for panel noise transmission acoustically, often used for quick design studies like this early in development, where the thickness, material properties, and damping of the panel can affect the transmitted noise. SEAM accounts for resonant transmission, or radiation, and non-resonant, also known as mass law or double wall transmission. Leakage can be included based on test data or estimates, and the total noise contribution through all the paths from the dominant noise sources will yield the overall interior levels, and this can also be viewed as a virtual contribution analysis within the software. The software will briefly be shown. The physical system being modeled is on the left. A source room to a receiving room through a base panel with porous trim or decoupler, foam or fiber, and then a heavier mass barrier. The equivalent SEAM network representation is shown on the right. Briefly stepping into this model, we can see the ease and speed with which the results may be calculated across frequencies, and the transmission loss or noise attenuation can easily be shown. This can be kept as a baseline, and the user can then do these quick and easy design studies. For example, increasing the decoupler or fibrous middle layer by 50%. That change is quick and easy to implement. The effect of that can be shown very briefly, and we can see the overall impact on the transmission loss. Other studies of this nature can be done, for example, changing the panel from steel to aluminum. That change can be propagated in and combined with the previous decoupler change, and we can see the overall impact or degradation improvement of transmission loss. This is a brief overview of the SEAM software provided by Cambridge Collaborative and also provided through Altair, and how it can be used for typical acoustic and vibration design studies, primarily at the higher frequencies.